Hi, today I'm going to talk a little bit about the evolution of my signals on my layout. I started off with these type of signals here from DCC SMBK, I believe they're called. And that one, as you can see, is six independent lights. It's two heads of green, yellow, red. So I went from using these lights to this type of light over here, which are searchlights. So now the top light, for instance, will be red, yellow, or green, and the bottom red, yellow, green. So now you only have like two physical LEDs, but each one can go three colors. So those are called searchlights. So originally, the way I had them connected is I built these type of these little decoders here. So that went. I made a hole in the sub road bed, and this guy was underneath the layout. So I just used a bit of hot glue to stick it underneath the layout, and then this guy plugged in from the top. And what's neat about these decoders is they are similar to the ones made by let me see, Team Digital made these decoders, and now they discontinued them. You can get them from RR Circuits. Very similar design. So what happens is they can operate on the turnout addresses. You see here, let me see, turnout address, base address is CV5 if you want to give it a turnout address, and a CV2 if you want to give it a signal address. And what's neat about that is because if you use the turnout address, well, then you can manually trigger the signals from your throttle, like this guy here. I just go from, let me see, I press this button here, and it switches from the locomotive to the turnout decoders. But what happens is you can't double up on the same address. For instance, if you use a turnout address and it's, let's say, 200 for that signal, but then on the layout somewhere you have an address 200. Well, when you flip it, the turnout will flip, and then that signal will flip. So you have to remember to keep let's say a batch of numbers for your turnouts, and then a batch of numbers for your signals. But and that I didn't like that idea. So one of the other, so as I said, is you can use some signal addresses with CV2. So in that case, you could actually have if you program the CV2 with an address of 200. And not CV5. CV5 you gave it, let's say, 0, address of 0. Then when you would trigger turnout 200, only turnout 200 would flip, and not the signal 200. And that's just like with the locomotive addresses. If you trigger a local, you can have a local with an address of 200, and it's not going to be start and go and be interfere with a turnout an accessory address of 200. So they all have their own ways of working. So in this case, I would use signal addresses, and then I would use JMRI, and it would do all the logic. So you would say, under this condition, if turnout such and such was flipped, well, then this headlight should go red and green and so forth. So for instance, this one right now, I actually have it set to address 200. So let me see. Right now, both headlights, sorry about the glare, but they're both showing red. So now if I go 200 and I go close, so now the top one flipped to green, throw, flip to red. And then if I go 201 will actually control the yellow light for that signal head. So that went to yellow, flashing is close, and then throw is solid. Then if I go to 202, so it will control the bottom signal mast. 202 close is green, throw is red. And if I go 203, I'll go yellow flashing for close, and 203 throw is yellow solid. So if I want them both to go red, I'll go 200 throw for the top one, and 202 throw for the bottom one. What happens is the way it is, it uses two addresses. Well, two addresses for each head the red and green, and then the yellow and flashing yellow, and then the other one uses 2 addresses. So altogether, a single mast uses 4 addresses. So, and what was neat about that is I would just see, you can power it directly from the track. You could just connect these 2 wires to the DCC bus. So that was very easily, when you have a lot of signals, it's very easy to wire them to each other. And if you ran a separate accessory bus, DCC bus, what's good about that is that if there's a short, you know, on the track, these lights would continue to work because they have a separate bus. So that was another implementation that I did. But anyway, I really liked that, and I enjoyed that for the longest time. The only problem I found is that I had to use, you know, software. I had to have a computer running, and let's say JMRI, and they would have all the logic to be able to control these signals. And I didn't want to have that. I wanted a more of a plug-and-play system, something that had all the smarts built in. So I came across the company MGP Mollahem, and they have some decoders, which I'll find in a second. Well, they're underneath the layout here. Let's see. Might be hard to see there. There's a few of them here. Some of them are signal decoders, and some of them are the panel decoders. They're basically the same board, except they're programmed with a different software. So in this case, what happens is you have this bus wire here, which is a servo type connection, and it gives out 5 volts in ground and then a signal. So to modify those signal heads, since you see it started off as something like that, and then I ended up putting these little boards here, which convert the this is a WS2811 chip. So it'll convert you know, the LEDs, will make them run with the with those boards. So basically, you have 3 wires coming in, and then you see in this case I have 2 of these tiny little boards, 1 for each head, because each little board does has an output for well, let's start off with the input is 5 volts in ground, and then signal in, and then actually on the back of the board is an out. So that you can see there's a tiny little gold pin there. It goes from the out of that board to the in of the next board, and then the 5 volts in ground are fed through, and then the back of this board has his out. Well, sorry, in this case this is the in. The arrow is the in. The top of the board is the out, and then the daisy chain's out. So you end up having 4 wires. See, in this case, I have this one would go to the next signal, the in of the next signal, like that, and then they would just daisy chain. So the thing is, I had to convert that board. I had to make a little connector like this here, so that when I unplugged from these boards, well, these signals were staying in the layout, but I wanted to connect the new hardware, so I had to convert from that other SMBK. SHD2. It was the decoder is called SHD2. The signal mass is SMBK. So the SHD2 decoders are being replaced with this little chip and that. But the smarts is done by that signal board that I just showed. So what happens is I had to modify that and then wire it up the right way so that now it would work with these guys. So that's the second evolution. And then the third evolution was when I went and I ended up buying these, again, which are the searchlights, and there's one with one signal head, or the other ones, as you saw over here, is 2 signal heads. So what happens is you would end up having either 4 wires come down or 8 wires come down. So there was a black, green, red, and yellow. So what I had to do is wire them up. I ended up buying a kit. Kit like this here. So you have these male pin connectors, and then a bunch of these guys. So what happens is I had to again figure out what the wiring was, and in this case it's I'll flip it this way. For me it was black, green, red, black, green, red, and yellow. So now what happens is I can end up plugging when I replace the signals, I can unplug the signals. See, now you'll have, it's actually broadcasting something there. So if I pull that out, I would have to, well, let's see if I can do this with one hand. Okay, so now this light is actually showing yellow. Again, might be hard to see with the camera itself, but that's plugged into now this decoder. So there's two halves there, because if there was a second searchlight, it would end up being connected to the back here of. Sorry, my finger, I smashed it with a drill. It's going back, but it's slow. So there's another row that I could actually plug in a second row like that, and then trigger that. So now what happens is that'll be triggered by the smarts in that board. And there, so I have two systems that are running these RGB LED type of signals, and it's one of them is the MGP, and then the other one is this one from Hans Stanner's project, IOTT project. Here I printed my own yellow box, well, gray box I guess now, and that's the M56C Plus. That's the one with the larger screen. This is the older one here, the smaller screen, too bright. Yeah. So that's connected to a Loconet box up here, and then the string just comes over here to this one. So his has some smarts in it where you can program under what conditions the signal will change, or the MGP one that also has some smarts in it. The other panel I have is this one here that is working with his box. Okay, so here's the LEDs lit up. I have, well, what you can see is a combination of green, yellow, and blue LEDs. So the green LED is going to tell me where, what route the train is taking, what routes are selected. The yellow tells me if the route is selected and occupied. And then the blue is the mountain line. So that's another set of tracks. So that goes to the mountain line, and they're all blue. And if the blue gets occupied, if the route gets occupied, well, then that blue turns to like a combination of two colors, and so it becomes like a purplish color. So that's how that's working. But again, you can work that. I can work that on Hans' system. Let me see. Yeah, see, I selected another line here, so that went to green. So now the mountain line is no longer selected. I can select another track here. See, then that track goes out. Then if I select the mountain line, which would be, let me see here, this guy. See, the blue goes on, and then all the mountain line goes, the non-mountain line goes out. I select this route that goes green. So it's a little hard to see with the colors with this, but anyway, that's the evolution of the signals on my. Thanks for listening. Bye.